Hey everyone, today we're going to be looking at motion graphs. So we're going to look at our first set of practice problems for interpreting motion graphs. So let's take a look at this. Okay, so we're going to be looking at 4 different graphs and answering some questions for each one of these. So I'm going to go through graph 1 with you so you can see how to do that. Okay, so the first question says, what is the initial position? So we're going to look at the graph, and the initial position is where it is starting. So the initial position here is right here. Okay, so now we have to figure out what number goes with this graph at this point. So if we look along the side, the position is in meters, and this is 0.5 and this is 1. So each one of these little hash marks is going to be 0.1 of a meter. So here's 0.1, here's 0.2. So this is 0.2 meters. So the first graph, initial position, is 0.2 meters. The next question is, what is the final position? So that is going to be the end of the graph. So for this graph, we see it ends right here. So we're going to look on our y-axis, and that is at 0.5 meters. So the final position is 0.5 meters. Question 3, what is the distance traveled on the journey? So we're looking for the distance. So remember that distance is the total of the whole trip. Okay, so this is the x-axis is what we're looking at. Okay, so here it's at 0.2, it's still at 0.2, and then we're going up. So we're going to start here at 0.2, and we're going to go up to 1.0. So the difference here is 0.8 meters. So I'm just subtracting 1 minus 0.2 gives me 0.8. Okay, whenever we have a flat line on a position time graph, that means that there's no motion. So that would be 0 meters. So just like the initial is no motion, here is no motion, so 0 meters. Okay, now we're going from 1, and it's traveling down to 0.5. So we're going to subtract again, 1 minus 0.5. So this is 0.5 meters. So we're going to add these up to get our total distance that this object traveled. So 0.8 plus 0.5 is going to give us 1.3. So if we're looking for the distance, we're going to add all of the x values. Okay, the next one is asking for the displacement. Remember, displacement is a little different. Displacement is the beginning position to the ending position, not the total, but just how far you are from where you started. So if we look at this graph, it starts here at 0.2 and it ends at 0.5. So this is the displacement from the beginning position to the ending position. So again, we're just going to subtract 0.5 minus 0.2, so that gives us 0.3 meters for the displacement. Okay. Okay, the next one is the average speed for the entire trip. So remember that speed is distance divided by time. Distance divided by time. So we already got the full distance of the journey right here. So now we need to look, what is the time? So down here at the bottom of our graph, it gives us the time. So 2, 4, 6, and another half would be 7 seconds. So to figure out our average speed is distance divided by time. So we're going to do 1.3 divided by 7 seconds. So total distance divided by total time. So remember, whatever's on top is what you're going to put in the calculator first. So 1.3 divided by 7 will give you 0.185. So we'll round that to 0.19 meters per second. Okay. Okay, the next one is, what is the average velocity? Remember that velocity is based off of displacement because it has direction with it. So we are going to do the displacement divided by the time. So for velocity is displacement over time, so 0.3 divided by 7 seconds. So whatever's in your calculator goes in first, divided by 7.04 meters per second. And what direction? Okay, so the displacement here, we have to have direction. So this is away, since our graph doesn't give us directions. Okay? Okay, so graph 2, 3, and 4 are very similar to this one. So go ahead and try to do the rest of those graphs. Have a great day.